Hey, what's up guys? Chung here again. And this time, let's take a look at this LeetCode problem here. Number 621, Task Scheduler. Okay, you're given a, a char array representing tasks CPU needed to do. It contains capital letters A to Z, which means there are only like 26 tasks, different tasks in total. And the task could be done without the original order of the array. Basically, you don't need to care about the ordering. You just need to try to execute all the tasks, right? But there is a cooldown time, basically, right? Basically, there's a cooldown time n here. This n means that between each of the task, right? Between each of the same task, you need to have at least this number of cooldown CPU time. For example, here A, between A and A, you need to have at least have two idle space. That's what this n means. Okay, and okay, and then it asks you to calculate the minimum unit of the CPU time to execute all the tasks, the minimum one. Okay, so for this problem, I think this one is more like a greedy approach, right? I think the way we need to think about this is we need to think about what is the most idle time we need, right? That's so basically the most idle space CPU time we need will be the maximum. Basically, we'll do a counter here. Okay, and we have a counter, so we count everything in the task, right? Basically, we count the tasks, and then the most count in this case, let's say it's 3, right? So the maximum task count in this case is 3. So, and we use this max count. So from this max count, we can get the maximum idle time we need for to be able to finish executing all the tasks, right? Because for this most frequent task, between each of the tasks, we need this nth idle time. So that's why in this case, it's going to be 3 minus 1 times 2. Why we do a minus 1? Because for the last one, we don't need the idle time after that. That's why we only need the 2 idle times. See, that's a two idles and then 2 idles. Between those 2 A's, we need like 2 idle times. And okay, so that basically that's the idle space. Idle space. The most basically that's the most idle space we will need so to calculate to execute all the tasks, and the rest will be just simply maybe to get the rest task, the number of the rest task, and then subtract those tasks from this idle space. So just as if we're having this like a space, right? We're having this different space here. Let's say we have a idle group here, group 1, idle group 2, and idle group 3, right? And we'll just try to fill all the other tasks inside of this like each of the idle group here. So we're gonna fill the B here and B here and B here, right? And then since we created these different kind of idle groups with the maximum count. So it's guaranteed that we can fill the rest. We can fill the rest inside inside of this idle groups here. And once we have tried to fill all the tasks inside this idle groups, we can just and then how many idle spaces remaining are the actual idle spaces we will actually need. Basically, that's gonna be our true idle spaces. And then once we have this updated, the idle space we'll actually need to execute all the tasks. We just need to, in the end, we simply do a idle space, idle plus the the length of the tasks. Okay. Yeah. So basically, I think I mean, the key concept here is since we need at least of those kind of idle spaces, right? We'll try to fill those idle spaces as many as possible with the remaining tasks. Okay, and then then after filling all the idle spaces without the remaining tasks, then whatever left, let's say we have something left here in the idle space, that will be our maybe the actual idle space we need, right? And then the rest will be the tasks. Okay, so then, like I said, we simply do a counter first, right? Counter equals to the collections dot counter task, right? And then we'll get the maximum count, basically the maximum. Uh, I'll do this sorted count, okay? Basically, I'll do a sorted list of the counter dot values, right? Basically, I want to sort this value. Since this value is like dictionary values, I'm converting it to a list, and then once I have the list, I do a sort. Now we have sorted count here, and then the maximum count. The maximum count gonna be the last element, right? Which will be the sorted count dot pop. So notice here, so why I pop it instead of I check the last one, because remember we use one of the most frequent task, right, to create those spaces, the idle spaces. So when we try to fill those idle spaces, we shouldn't count that the last one. We should like try to fill those spaces with the remaining tasks. Okay. Now we have the task. So and then we have idle spaces, right? So it's going to be the idle space. Okay. So how many in total, right? How many idle space in total we need at the beginning? That's going to be the max count minus 1 times n, right? Like I said, since the last task doesn't need the idle, that's why we only need this max count minus 1 times n's idle space. And then we simply do this while we simply just remove everything from try to fill this idle space with everything left in this sorted count here, right? And then we do what? We simply do a idle space, right? Minus the what? You know, I think you may come up with something like this, right? This is kind of right, but you have to do a minimum like this. Minimum this one and the maximum count minus 1. So why you need to limit with the current maximum value here, the value here, is because, and it's because let's say you have two, yeah, let's for example this one, right? So the maximum count is 3, right? But when we create the space here, we are using the two spaces times 2, right? And then the next time when you remove the try to remove b, right? You try to fill those spaces with the b here, but the b has the count equals to 3, okay? But instead of 3, actually the most we can fill is maximum count minus 1, which is 2. That's why we need to use a minimum to make sure this, in case there's another another task that has the same max count, we only fill the max count minus 1. Because remember, this idle space, we're trying to remove the idle space, not the actual count itself. So basically we have to somehow convert that count to this idle space. Okay, I'll draw a quick picture here. Let's say we have A here, right? So A idle space A, right? And then idle space A, right? So basically that's how we define the idle space here. Basically we to be able to execute everything here besides A, we need 4 idle space, right? And then when we try to fill this idle space with B here, okay? So how many idle space can B fill, right? B can fill like here 1 and then 2, right? And then actually the count of B is 3, so the third one will be filled right here, right? So the third one will be filled here. But it doesn't really matter, right? Because all we care is the how many idle space we can decrease from the current count. That's why even though the count of B is 3, the most we can subtract from the we can fill into the idle space is still limited to this max count minus 1. And let's say assuming we have a C here. Let's see the count of C is 2. Okay. So in this case, I mean, we can certainly add C and C here, right? That's why we have to limit this like sorted, the limit the space we can fill, the idle space we can fill with this max count minus 1. Okay. So, and okay, and then in the end, right? In the end, we simply do we have a return. We simply return the idle space, whatever the idle space left. Okay, plus what? That's the idle space. We also need to plus the time, the task. Right. So the task, I'm gonna create an n here. The length of tasks here. Okay. So here I just return this one. And this should just work, this one. Okay, let's try to submit it. Oh. Okay, yeah, so this is a special case. For example, here the if the idle, sorry, the interval is 0, which means our idle space will be equal to 0, right? And then basically the maximum idle space uh, we need in this case is 0. Mm, yeah, let me see here. Yeah, okay, so in this case, I mean, I think there's another case here. Let's say if we continue with our previously example here, A, right? A, A, and A, right? So let's say here we have A, B, 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 let's say, and then we have a C, C, and D, and D, okay? So in this case, after filling the A and B, sorry, after filling the B and C, our idle space have already been reduced to 0, right? Because we have B, B here, and C, and C. Now we have a D here, okay? And so basically every time when we see, maybe we can do a quick check here. Basically, whenever the idle space becomes to 0, then it means we don't need any actual, we don't need we don't need to add any actual idle space. All we need is all the length we need will be the length of the tasks. Okay, because here we'll be having like a D and A B C A B C A B and then D, right? Yeah, because in that case we need a negative idle space because that's the basically that's as long as we keep executing this tasks in sequence, we won't need any idle space. So in that case, we simply return the length of tasks. Okay, so mm, if not idle space, right? If not idle space, or if I do a if idle space equals to 0, right? I simply return I simply return n, right? Otherwise, I'll just return this. Okay, let's try to run it. Hmm, 0. Oh, sorry, not equals to 0 because here the at the beginning it's already 0. So also we should check this. We should check at the beginning here, even before decreasing the size of the idle space. So this should just work. No? Uh, uh, I think I know. So hmm, So, I shouldn't have used the n here because n is like the previous one. N has been used. I'll just use this. I will not create a separate one here. Okay. Yeah. So yeah, this should just work. Yeah, because at the moment we see this idle space either equals to 0 or it's less than 0 after decreasing the amount. We know, okay, we need actually we won't have any actual idle space, right? In that case, all we need is the number of tasks. That's the total CPU time we need. Otherwise, if this idle space is greater than 0, and then we know, okay, other than the length of tasks, we also need to add this many idle space to keep this minimum intervals for each of the tasks. Okay. So the time complexity of this is is O of n. So sorry, the n is the length of the tasks. So the O of this. So why is that? Okay, so first, I think the O of the length of tasks coming from here, right? So in order to get all the counters here, inside this collection.counters, we have a for loop. Basically, we have a for loop to loop through all the counts, right? So here's gonna be the O of, I'm gonna have m here. Yeah, since we have n here, so that's gonna be O of m. And then when we do the sorting, right? So you may be seeing you may say that, okay, so we have a sorting here, so we shouldn't be like O of log n, right? The m log m. No, it's not, because the tasks is only limited to A to Z, right? And then that's why the number of the counters dot values is only bounded with 26, right? So sorted a list with only 26, it's gonna be a O of 1. Right, so we treat this sorted with only a maximum of 26 elements to 0, 01. And same thing here. That's the while loop for sorted account is also a while loop of 26. And we're also treating this part as like 0, 01. So the total time complexity in this problem is O of m. M is the number of tasks. Okay. And the space how about the space complexity? So all the space complexity we have is the counters and also the sorted count. Okay, so both of this is just and the this is just like an integer, right? So this one does not count any space. So only these counters and sorted count, and each of them is also bounded with 26. So the space complexity for this one is 01 with constant size of the list or array. Yeah, I think that's it for this problem. Yeah, do a quick recap. So the key idea here is that we have to observe this like this mm, like this intervals. So we have to be able to come up with the maximum idle space we need is the maximum count of the tasks and -1 times n. That will be our maximum idle space we need. And once we have this max idle space, all is left is just try to fill this idle space with the remaining tasks. That's why we do a pop here to eliminate the to eliminate task used to create the idle space. And then we just try to fill the space with the remaining tasks. And then here is just like a simple it's like early terminations. It's not, we don't have to do it here. We can also check it in the end, check if the idle space is greater than 0 or not. If it's not, then we simply remove the just return the length of tasks. Otherwise, we return this. Okay, so yeah, I believe that's it for this problem. It's a, you can call it a greedy problem, or it's mm, I'm not even sure if it's categorized as a greedy problem, because all we did was the just to get the maximum count here, right? And once we have the max count here, we don't need to sort this count anymore, right? All we need to do is we just try to maybe, I mean, try to fill or remove all the tasks, all the remaining tasks from this, subtract the remaining tasks from this idle space integer, right? And it doesn't really matter if this thing is sorted or not. Mm, mm, sure, yeah. Or if we are trying to use like a greedy concept here, so let's say we have a, you can think it in this way, uh, a right, and a. So think it in this way. So the reason we sort it is because we always want to fill in the idle space with the most frequent task. In this case is B, right? So basically we fill B first, and then we fill the next uh, most frequent tasks, right? With like C or C and then D, right? Mm, yeah, I think you can think it in that way. And then that will be a more obvious greedy logic solution here, right? Basically, we are trying to fill in the idle space every time. We always try to fill the most frequent one, because that's the optimal step of the current state, right? We try to fill the most frequent one as early as possible. Mm. Yeah, I think it is a greedy problem. Cool. Okay, thank you guys for watching the video, and let me know if you guys have any questions or any suggestion. And yeah, every day learn something new. Cool. Thank you so much. See you guys. Bye bye.